Today we will start quadratic equation. It's a very small chapter and easy chapter also, but its application is extremely important in algebra. So before starting quadratic equation, let us first learn some definitions in order to come into quadratic equation. Real polynomial. What is a real polynomial? If a0, a1, a2, an be the real numbers and x is a real variable, then this type of equation a0 plus a1x plus a2x square an x to the power n is a real polynomial. See example, these things are not difficult, you have already seen this type of equation, but maybe you have not noticed about these terminologies. See 2x cube minus 6x square plus 11x minus 5. This is a polynomial equation. Now what is a complex polynomial? If these terms are in complex, see one example, 3 minus 2y x square minus I into x plus 5. This type of equation are complex polynomial. Why? See the coefficient of x square, coefficient of x are complex numbers. If a0, a1, an are complex numbers, then this type of equation or this type of equation are known as complex polynomial. Degree of a polynomial, the highest power is known as the degree. If you have let us say in this equation, what is the degree? Highest power of x. So what is the highest power? 3. So degree would be 3. So if we have polynomial something like this, then our highest power is n, so our degree would be n. The highest power of x is known as degree of polynomial. A polynomial equation, if fx equals to 0, if you make this polynomial equals to 0, then that thing would be known as polynomial equation. Roots of an equation, the values of x which satisfies this polynomial equation is known as roots of an equation. So let us say fx equals to 0 is a polynomial equation and x equals to alpha satisfies this equation, then f of alpha equals to 0. After calculating f of alpha equals to, if you put alpha in place of x, you will see that f of alpha equals to 0. That means that polynomial fx is alpha is a root of that polynomial. If that satisfies the equation, then alpha would be a root of that equation. Now let us see solution set. So it is not mandatory that you have only one solution. You may have 3 solutions. If this is 3 degree polynomial, then you have 3 solutions. If you have 2 degree polynomial, then you have 2 solutions. So let us say if you have let us say 1 to 3 is the solution set of this. See, you have 3 degree polynomial, so you would have 3 solutions. Put 1 here, you will get 0. Put 2 here, you will get 0. Put 3 here in this equation, you will get 0. That means that is these are the solution, and all the solution written in the curly brackets are known as solution set. Now what is an identity? An expression involving equality and a variable is called an identity. Let us say x square minus 9 equals to x minus 3 into x plus 3. This is an identity as is satisfied by every value of, if you put any value of x, the left hand side would be equals to right hand side, then this type of thing is known as identity. Now what is the fundamental theorem of algebra? Every polynomial equation, that is, let us say fx equals to 0 is a polynomial equation, has at least one root. That root can be real or imaginary. So that means every polynomial fx equals to 0 should have one root that is real or imaginary, but it should have one root. It should have at least one root. That may be real, that may be imaginary, but it must have one real root. See, if this equation, this identity, or if you make this x plus 2 here in the left hand side, then that would be a polynomial equation. This has one root. But see, if fx equals to root x plus 3, this thing, this fx equals to root x plus 3, if you make is equals to 0, then it has no solution. So it has no root actually. It has no root because see, if you make this root x equals to minus 3, so something root can never be minus. Root of something can never be minus. Okay, root of something can never be minus because we know within the root it should be positive. So these are the terminologies. let us come to the next slide. Continue. See what is a quadratic equation. A polynomial is in the form of ax square plus bx plus c equals to 0 is known as quadratic equation. Quad, that means it highest power 2, quadratic equation, where a should not be 0. See, if a is 0, then x square term will be omitted out, then it would be a linear equation, not a quadratic equation. And the coefficients a, b, c can be real or complex. If it is a quadratic equation, then it should have maximum of 2 roots. If it's a trinomial equation, then it have 3 roots. The things goes like this. See, if you have this equation x square plus bx plus c equals to 0, apply Cbse rule, you will get x equals to something like this, minus b plus minus root under b square minus 4ac by 2a, where you can take plus sign for one root and minus sign for another root. So when you have taken plus sign, then it will be, let us say this is alpha, let us say this is alpha root, and when you have taken minus, then it would be beta. So this quadratic equation has 2 roots, alpha and beta. Now this square root term, b square minus 4ac, we already know whatever it is in the square root or in the root, it should be greater than 0. It should be greater than 0 because negative of square root is undefined. Here b square minus 4ac is known as a discriminant. B square minus 4ac is known as discriminant of quadratic equation. If this discriminant 0, that means b square minus 4ac equals to 0. If this discriminant 0, that means b square minus 4ac equals to 0, then alpha and beta both the roots are same. If discriminant equals to 0, then alpha and beta both roots are same, that is given by minus b by 2a. So remember this, if discriminant equals to 0, you have real and equal roots, because in the exam they will ask you about the nature of the roots. That is the most important part, nature of the roots. So first find out the roots, after that see whatever is the value of discriminant. If it is greater than 0, if it is less than 0, if it equals to 0, if it is a perfect square, then according to that our roots will change. So if b square minus 4ac discriminant equals to 0, then both of the roots are equal to minus b by 2a, and the roots, the nature of the roots would be real and equal. If discriminant is a perfect square, if this discriminant is a perfect square, then roots will be rational and unequal. Remember this, if discriminant is a perfect square, then our roots will be rational and unequal. If discriminant is greater than 0 but not a perfect square, discriminant is greater than 0 but not a perfect square, then roots will be irrational and unequal. Here rational and unequal when discriminant is perfect square. When discriminant is greater than 0, that means b square minus 4ac is greater than 0, then our roots will be irrational and unequal. If this discriminant is less than 0, then you will have, our roots will be imaginary. Our roots will be imaginary, and those two roots are given by minus b plus I root under of same thing, and minus b minus I root under of this. This I represents for complex numbers. The value of I is root under of minus 1. The value of I is root under of minus 1. Then if discriminant is less than 0, then we can say that our roots will be imaginary, and those two roots are given by alpha and beta. Always remember, if discriminant is greater than 0, then our roots will be complex conjugate. Now what is a conjugate? See, if you have alpha equals to something like this, 3 plus 4i, then beta would be 3 minus 4i. Same thing, but you will have a minus here. These are known as complex conjugate. If alpha equals to 3 plus 4i, then beta would be 3 minus 4i. These are known as complex conjugate. That's why it is written that is alpha equals to beta bar and alpha bar equals to beta, this bar. When we learn about complex number, when we learn the chapter, we will see how these things came. Complex root of an equation which with real coefficients always occur in conjugate pair. So remember this thing, I am again repeating it. If discriminant equals to 0, your roots will be real and equal. If discriminant is a perfect square, your roots will be irrational and unequal. If discriminant is greater than 0, then your roots will be imaginary and unequal. If your discriminant are less than 0, your roots will be imaginary, and those will occur in conjugate pair. That means if you have one solution as 3 plus 4i, another solution would be 3 minus 4i. These things are known as complex conjugate. Let us solve one problem. See, the question is given x square minus 7 minus I into x plus 18 minus I equals to 0. You can clearly see that if you compare this equation with ax square plus bx plus c equals to 0, then here a is plus 1, b is minus 7 minus I, and c is 18 minus I. You can clearly see this thing. A is 1, b is minus 7 minus of 7 minus I, and c is 18 minus I. So from Siddharacharya we can say that alpha is minus b plus root under b square minus 4ac by 2a, and beta is minus b minus root under b square minus 4ac by 2a. So put the values of a, b, c here. Put the values of a, b, c here. After simplification you will get these two things. Now let minus 24 minus 10i. See, here also minus 24 minus 10i. Let minus 24 root under of minus 24 minus 10i equals to a plus ib. This is the complex representation of a complex number. You can represent any complex number as a plus ib, where a is in real axis and b is in imaginary axis. So any point can be represented as a plus ib. This is a plus ib, this is a plus ib, and this is your z, mod z. So this is the representation of complex number. As we have I here, so this the answer would be in the complex solution. So a plus ib, let us say a plus ib equals to root under of minus 24 minus 10i. Square both hand side, so a plus ib whole square equals to minus 24 minus 10i. Break a plus b whole square. A square plus 2ab minus a square plus 2ab plus b square. See, I into b whole square. That means we got I square b square. I have already told that I is root under of minus 1. So I square would be minus 1. So I square would be minus 1. So you will get minus b square. So when you square the b square ib whole square, you will get minus b square. So a square minus b square plus 2ab, and right hand side as it is. Now a square minus b square equals to, take this term in the right hand side. See, compare both sides. Here the real root, here the real part is a square minus b square. Here the real part is minus 24. So a square minus b square should be minus 24 in order to satisfy this identity, right? So a square minus b square should be minus 24, and 2ab should be minus 10, because I is in both sides. This is the complex part. This is the real part, and this is the complex part. So equate real part in the both hand side and complex part in the both hand side. So we got a square minus b square as minus 24 and 2ab as minus 10. Now see, we know that if we square a square plus b square whole square, what would it be? It would be a square minus b square whole square plus 4ab. What is the formula of a plus b whole square? A minus b whole square plus 4ab. So a square plus b square whole square would be a square minus b square whole square plus 4a square b square. Now see, we know a square minus b square equals to minus 24. Now put the values of a square minus b square here, which is minus 24 square, minus 24 square is 576. 2ab value is minus 10, so 2ab, so you can write it as 2ab whole square, so minus 10 square will be plus 100, 676. So after square root, square 26, after square root you will get 26. So a square plus b square is 26, a square minus b square is minus 24. Solve this 1 and 2, you will get a as plus minus 1 and b as plus minus 5. See here 2ab is minus 10, so ab would be minus 5. That means you can see that multiplication of a and b equals to minus 5. So what would be the combinations from this a and b? A can be minus 1, B can be plus 5, so multiplication would be minus 5. A can be plus 1, B can be minus 5, so multiplication would be minus 5. So what is the answer? A plus IB, A is either plus 1 minus 5, minus 1 plus 5. If we take plus 1 minus 5, then A minus IB, A plus IB would be plus 1 minus 5i, and if you take minus 1 plus 5, then it would be minus 1 plus 5i. See, we have taken this thing, A plus IB is actually your root under of minus 24 minus 10i. So what is the value of minus root under of minus 24 minus 10i? It is A plus IB. So A plus IB, A plus IB, this is A plus IB. So root under of minus 24 minus 10i should be plus minus 1 minus 5i, 1 minus 5i. Now substitute this value in this equation and this equation. So root under of minus 24 minus 10i is plus minus 1 minus 5i. So put plus at this equation and put minus at this equation. After that solve, you will get 4 minus 3i as alpha and 3 plus 2i as beta. So this is our answer. 4 minus 3i is one root of this equation and 3 plus 2y is another root of this equation. This type of problems are extremely important, and you look into this problem and this type of practice more problem from the book. And let us see in the next slide some more topics. Left with very small topics. If we have quadratic equation ax square plus bx plus c equals to 0, from 9 and 10 standard we already know this, but still we have to learn this. Let the root of these equations are alpha and beta. So sum of these roots would be, see, if you divide by a, x square plus b by a into x plus c by a equals to 0. If you divide by a, then alpha plus beta would be minus b by a, and alpha into beta would be c by a. So any quadratic equation can be represented as, if you know the value of, see, sum of roots is minus b by a, product of roots, this is known as product of roots, is c by a. Any quadratic, if you know the roots of the equation, any quadratic equation can be written as x square minus alpha plus beta into x plus alpha beta equals to 0. Apply this thing when you know the value of roots. We will learn more about quadratic equation and apply the concept of quadratic equation in the chapter complex number. So stay tuned for our next chapter to upload in the YouTube, and hope you are enjoying it. Thank you.